What's up everybody, welcome back. So it's part 8 already of the multiplayer mech series, and in the previous episodes we set up our health stuff so the AI can kill us and we can take them down. But at this point we only have 4 AI in level, and I want to take a look at spawning actual AI so we have a bit more of a game going on instead of just these 4 enemies that we need to take down. So that's what we're going to do in this episode. We're going to take a look at spawning in the AI. But before we do that, I want to take a look at a little bit of optimization. So we're going to start in our enemy base, and in here, in our attack player event, we actually call a multicast to play the attack montage, and because we probably end up with a bunch more enemies in the level at this point, it might be a good idea to actually replace this with a RepNotify variable. So the multicast is always a bit heavier on the bandwidth than a RepNotify event. So if you can use a RepNotify for things like this, then it's probably a good idea. Because I mentioned there are going to be a bunch more AI in the level, so otherwise we are going to have a lot of multicast events firing off. So let's do that. We're going to create a new boolean, and I'm going to call this trigger fire weapon. And as I mentioned, we're going to turn it into a RepNotify variable. So over here, replication, select RepNotify, and then it will create this function. So first of all, let's implement it over here. So we're in the attack player event, and we're going to replace the multicast call with the trigger RepNotify event. So just hook it up like this. And then we need to make sure that the RepNotify actually changes every time, because if it's not changed by the server, then this function will not fire on the clients. So if it's false and the server sets it to false, this will not execute. It actually needs to change. So we're going to grab the current setting, and then we're simply going to flip it around by entering a not boolean and then plug it in over here. So with a setup like this, you can actually use it as a trigger to trigger an event. Now we cannot override this function in our child blueprint, so we need to create an event that we're going to override and then call that event inside of this function. So let's create a custom event, and I'm going to call this trig fire weapon. And then we want to call this event inside of the newly created function. So let's double click this and simply call our trig fire weapon event. And now we can override this inside of our child blueprints to make sure it actually works. So let's grab our child blueprint for Wraith over here. And then we're going to go to the multicast call, so that's the event multicast attack montage where the actual montage is played, and this will trigger the notify that will trigger the sound and the emitters. So that's already taken care of. All we need to do is get rid of this event, and we're gonna replace it with our trig fire weapon event. So select the event one and simply hook it up over here. So this will make sure that when the RepNotify variable is changed, this will fire instead of the multicast. So that's taken care of, and since we're already looking at a different way to play multicast events and animations and sounds and things like that, there's a small thing I want to show over here as well, and that's you can actually use sound notifies inside of animations to play sounds. And because animations play on all instances, you don't need to replicate those because the playing of the animation itself is already replicated. So what we can do is open our animation GDR folder. And apparently it takes a little bit. So I'm going to grab the one in my example as well. And what we actually want to do is go to all of the walking events, or montages, sorry. So let's start, this is turn montage. So let's start with the walk backwards, for example. And we want to drag to the point where the footsteps actually hit the ground. So the first one is right at the beginning over here. And then we can add a notify over here. So if we right click, add notify, and then we are going to select a play sound notify. And then by selecting this notify, we can say what sound actually needs to play over here in the details panel. So I've been using the sound Rock Impact 11Q. So obviously that's not the greatest sound for a footstep, but we have to work with free assets that are actually available for everybody. So that's why I picked this one. You can choose any sound you want, obviously. So I'm going to use the Rock Impact and then 11 and the Q. And if we set it up in here, this will actually play for all of the players without setting up replication. So I'm going to lower the volume a little bit, 0.5, and that should be fine. So let's drag it to the next point where the feet are hitting the ground. So that's somewhere over here, frame 27. And then we're going to do the same thing. So add a notify, play sounds, and we want to select our Rock Impact and lower the volume a bit. So that's all we need to do, and we want to do this in all of the walking animations. So I'm going to go to the walk forward, and over here is actually at the beginning where the foots hit the ground as well. So right click, add notify, play sound, and I'm going to play the Rock Impact cue. So I've already selected it in the content browser by clicking on the little browse icon here, and if you add the notify, then it will automatically set it over here. So now all we need to do is change the volume and then go to the next footstep over here. So again, frame 26, 27 something. Right click, add notify, play sound, and lower the volume. And now all we have left is walk left and walk right. So the first frame over here, add a notify, play sound, and lower the volume. So you kind of get what's going on by now, and I'm simply going to do it for every footstep where it hits the ground. So I'm going to add one over here, frame 26. And then the last thing is the walk right animation. So again, frame 1, play the sound and lower the volume. And then around frame 26 over here, do the same thing. There we go. So now we have a footstep sound, and we're gonna double check if the fire montages for the enemy actually still play and if they replicate. So I'm gonna do a 2-player setup and simply hit play. And now we should still see the same thing for the client and the host as we did before, but we should also have footstep sounds for the mech. And since the enemies keep firing, let's just get rid of those guys so we can actually hear the sounds. And there you have the footstep sounds, so that's working, and the enemies were actually working as well with the fire montages and the muzzle flashes and the fire sounds. So the RepNotify is also working, so that's good. At this point we're ready to start to take a look at the spawning, so let's do that. So first of all, to set up the spawning, we're going to create an actual actor that will behave as an enemy spawner. So I'm going to go to the root folder and create a new folder in here and call this gameplay. Open it up, and in here we're going to create a new blueprint class, and that's simply an actor. So I'm going to call this my BP enemy spawner. And open it up. So it's pretty simple what we're going to do actually. This is just an, well, basically empty actor that we want to place in the level so we can specify the location where we want to spawn enemies. So the first thing I'm going to do is grab a scene, and that's a root component, and replace the default scene root. Then I'm going to add a billboard component so we can actually see where this thing is in the level. And I'm gonna raise the billboard up a little bit, probably about 60 units, and replace the actual billboard. So we should have a spawn AI billboard in here, so that's what I'm gonna use, AI spawn point. And this is actually under the engine resources, so if you don't see it, then you probably need to enable show engine content over here, and then it should pop up. So it's over here. So I'm gonna select the spawner billboard over here, and then I'm gonna add an arrow so we can see what direction it's actually facing. And I'm gonna attach that to the billboard and also raise it up a little bit. So that should be all. Compile and save this for now and close it. We don't need it anymore for now. Most of the spawning we're gonna set it up in the actual game mode. So let's go to the framework folder, open our BattleMechs game mode. And in here we haven't actually done anything yet. So let's open the full blueprint editor and we're gonna set it up in here. First of all, let's create two arrays. The first one is going to be all players. All players. And this is going to be of the BP player mech type. So player mech. So that's simply our character. And then we're gonna right click over here to turn it into an array. And we're gonna create a second array, and those are all spawners. And that's of the type BP enemy spawner. And that's also an array. Let's start with our begin play event. What we want to do in here is get all actors of class. And we want to get all of the spawners in the level. So we're going to select our enemy spawner over here. And then simply store it in the array that we just created. So the all spawners array. That's good to go. Then we're going to right click and we're going to look for event post login. Select this one. This will fire when the player has logged in and has a player controller, as you can see by the comment over here. So we're going to drag off the player controller object reference and we want to bind an event to onPossessed pawn changed. So bind event onPossessed pawn changed over here. Hook it up to post login, and then we're going to drag off here and create a custom event, and let's call this possessed pawn changed, for example. That's fine. And what we're going to do in here is add all of our players to the all players array. So first of all, we're going to grab the new pawn and we're going to check if this is valid. So this event will also fire, for example, if you enter the lobby in a multiplayer game, and then the actual player controller also changes. So we need to make sure that this only fires for our mech pawn when we need it. So we're going to check if this is valid, and then we're going to cast it to our player mech. And if this is true, then we're going to add this player to the array of all players. So we're going to simply grab the array over here and look for an add node and hook it up over here. So this way we're going to end up with all of the players in an array. So we can actually send AI that we spawn to different players, and they will divide their attention among players like we set it up. So that's good to go. Then we need to create a bunch more variables. So let's do that first. The first one is a boolean that's called isMultiplayerGame. So isMPGame. Turn it back into a single variable by right clicking, and then it's a boolean. Then we need the isSpawner cooldown. So isSpawner cooldown. And this is actually an array of booleans. So keep it boolean. If you right click, this will turn into an array. The next one is maximum AI alive. So max AI alive. And this is going to be an integer and just a single variable, so not an array. Then we need the player AI count. So player AI count. And this is going to be an array of integers. So right click it. And I'm going to explain what these variables will do in a little bit, so don't worry about that. The next one is the spawn interval. And that's a single variable, and then we're going to turn it into a float. And then we have the last one, and that's the spawner cooldown delay. So add another float, spawner cooldown delay. Like so, and as I mentioned, that's a float. So we're going to set up the spawning loop, and we're going to start doing that by creating a new custom event. So create a custom event in an empty spot, and I'm going to call this start game. So this will set up a bunch of the default variables that we're going to use. So first of all, I'm going to grab the spawn interval. And this is simply the time in between spawning different enemies. So I'm going to set it to 3 seconds to begin with. And then we're going to drag in our spawner cooldown delay and plug it in. And I'm going to set this one to 2 seconds to start with. And so this is actually the cooldown for a single enemy spawner in the level. So if we pick one spawner in the level and that one spawns an enemy, then it will have a 2-second delay before the same spawner can spawn a new enemy again. So this will make sure that we spread the spawning a little bit and don't keep spawning AI at the same spawn point. So that's the cooldown delay. Then we're going to grab the maximum AI alive, and this is actually the maximum total AI that is allowed to be alive at the same time in the game. And when we start the game, I'm going to set it to 6. And we are actually going to change these variables during the gameplay to increase the difficulty of the game. So the maximum AI alive, that's 6, that's fine. Then we need to grab for each loop for all of our spawners. So we're going to grab all of our spawners array. If you hit press F on the keyboard and then click, then you get a for each loop. So we're going to connect it and hook it up over here. And what we want to do, we want to create an entry in our spawner cooldown array for every spawner that we have in the level. So we're going to drag in our isSpawner cooldown array, and we're going to set an array element. Hook it up to the loop body, and then for the index, we're going to hook that up over here as well. We need to set the item to false because the spawner is not cooling down, and then we're going to say size to fit, so it will expand the array. And if this loop is completed, this array will have the same amount of entries as our spawner array, and all of them will be set to false. So we have something to start with at the beginning of the game. Then we're going to grab the completed pin, and we're going to hook it up to a branch over here. So make sure you hook it up to the completed pin and not to the set array element node. Let's clean this up a little bit. And at this point, we're going to check the amount of players in the game. So we're going to grab all of our players, the array, and we're going to get the length of the array. So that's simply the amount of entries of this array, and we're going to check if this is greater than 1. So look for greater than and enter 1 in here. That's our condition. So if this is true, then we actually have a multiplayer game. So we're going to grab our isMP game and set it to true. And in the other case, let's just set it to false. It already is, but this will make it look a little bit clearer. And if we actually have a multiplayer game, then we want to increase the maximum amount of AI alive. So I'm going to grab a setter for our maximum AI alive. And I'm simply going to multiply this with the amount of players in the game. So grab a getter for it as well. Drag off here, and we're going to look for a multiply node. And then we're going to multiply it with the length of the whole players array. So we can copy and paste it over here, hook it up, and plug it into the setter. And then we also want to grab our player AI count array and add entries for that for each player in the array. So what this array will do, first of all, let's hook it up, then it's probably a little bit easier to understand. So we're going to grab all of our players, grab a for each loop by pressing F and clicking. And we're going to do the same thing as we did with the array of booleans. So we're going to create an entry in the player AI count array for all of the players that are in the game. So let's drag off here and set an array element. Plug it in the loop body, connect the array index, the item is going to be 0, and we're going to enable size to fit. So as I mentioned, each player has its own entry in this array. And this will simply keep count of how many AI are attacking that player at this point. So that way we can send the newly spawned AI to a player that has the lowest player AI count. So we're going to use that to divide the attention of the AI evenly among players. So they will have always have AI attacking them, and not all of the AI will attack the closest player and the other players have nothing to do. So that's what we're going to do with this array. So we only need this in multiplayer, we don't need it in a single player game. So that's actually good to go, and that's the entire function that we're going to set up over here. Then we need to create the actual spawn loop. So let's go to an empty place. No, we're not going to create the spawn loop yet. First of all, we're going to create an event that will increase the difficulty. So let's right click and create another custom event, and I'm going to call this the increase difficulty timer. So increase difficulty timer. And the first thing I'm going to do in here is add a delay of 30 seconds. So before we're actually adding rounds to the game, we're simply going to increase the difficulty every 30 seconds. In the next episode or the episode after that one, I'm not sure from the top of my head. But then we're going to create a round system. So we're going to have one round. If the round ends, then we're going to go to round 2 and then the difficulty will increase. So to begin with, we're going to simply loop it every 30 seconds and then increase the difficulty. So add a delay of 30 seconds. Then I'm going to add a print that will simply say difficulty increased. So we know that's actually happening. And you can set up all kinds of formulas to do this, but I'm going to keep it pretty simple. So first of all, I'm going to grab a setter for the spawn interval, grab our current spawn interval, and I'm simply going to subtract half a second. So let's subtract. And then change this to 0.5, and then we need to make sure we clamp it so it doesn't exceed any ridiculous values. So I'm going to clamp the float, and the lowest value in here I want it to be 1 second, and the highest value is 3 because that's where it actually started over here. And then plug it in. So the spawn interval will never be lower than 1 second. The next thing is the spawner cooldown delay. So let's grab a setter for that one as well. And I'm going to do pretty much the same thing. So I'm going to subtract half a second from the current cooldown delay. And then make sure we clamp it so we don't get any ridiculous variables that will make it unplayable. So the lowest value is going to be half a second and the maximum value is going to be 3. That's fine. Over here it was 2, so that should work. Make sure we hook up the actual return over here. Then we need to increase the maximum AI alive. So I'm going to grab a setter for that one as well. And grab the current value, and I'm simply going to multiply it by 1.3. So let's multiply. And then I'm going to turn it into a float over here. So right click and then to float single precision. That's fine. And then change it to 1.3 and hook it up over here. So it's going to truncate the float. It's going to get rid of the decimals. And then we're going to set it. And at the end over here, I'm going to add a little print to actually show what's happened to the difficulty. So I'm gonna do print a text, and I'm gonna use a text so we can actually format the text. So drag off the in text and look for format text. And in here I want to say the new values. So first of all, let's start with the spawn interval. And then I'm going to do open curly bracket A, close curly bracket, hold shift and hit enter. And then we're going to enter a second line, and that's the spawner cooldown. So this is going to be value B. So curly bracket open, B, curly bracket closed. Hold shift and hit enter, and then we're going to say the maximum AI alive, and that's the C value. So curly bracket open, C, curly bracket closed, and then we can simply hook them up over here. So we have the spawn interval, and then our spawner cooldown, and then the maximum AI alive. So this way we can actually see what happened to the values, and that the actual difficulty changed. So I'm going to increase the duration over here to 10 seconds so we can actually read it. And let's change the color to something green, so that makes a little bit more sense. And then when this event is done, we're simply going to call it again. So we're going to increase the difficulty timer. So we're going to keep looping this event, and then it will simply start the 30-second countdown again and then increase it again. So that's our difficulty increase. And as I mentioned, later we're going to change this to increase the difficulty at the start of a new round. But for now, this will work fine. So that's all good to go. And before we actually set up the rest, we need to create an interface that we're going to use. And we also want to go back to our spawner. So let's take a look at setting that stuff up first. So as I mentioned, we're going to use an interface. And if you're not familiar with interfaces in Unreal Engine, it's basically a blueprint that we're going to create where we're going to define empty functions. We're going to add that interface to a certain actor. So in our case, we're going to add it to our game mode. And then from other actors, we can simply call interface functions without having to cast to our game mode. And those interface functions will only actually fire if the interface is implemented in the targeted actor. But if that's the case, then it will save us casting to our BattleMechs game mode. So in this case, for our game, it's really not needed, to be honest, because our BattleMechs game mode will always be running. We only have one game mode because we only have one type of game going on, and we only have one level. But in a bigger game where you have multiple game modes for different levels or different types of games, then this will be pretty useful. So that's why I'm going to show you how to implement it, and we're still going to use it in this project, although it's not really necessary because our game mode is loaded into the memory anyway. So we could simply cast to it because, as I mentioned, it's loaded, so it doesn't hurt to cast to it. But long story short, we're going to use an interface. So let's go to the root folder, and I'm going to create a new folder in here and call this interfaces. Open it up, and in here we're going to create a blueprint interface. So go to the blueprint section over here and select the interface. So let's call this our BPI for blueprint interface, and then game mode, and open it up. Oh, I didn't spell that correctly, but I'm going to fix that in a sec. So as I mentioned, the only thing we can do in here is add empty functions. So the first one we're going to add is reset spawner cooldown. And what we want in here is to add one input. So we're going to add an input to this function. And this is going to be our spawner index. So that's going to be an integer. And later, if we add this interface to our game mode, then we can actually define what this function does. So we don't have to worry about that yet. We are going to create a second function in here, and that's our AI died function. So let's create a new function, call this AI died. And for this one, we're also going to add one input, and that's going to be the targeted player index. So targeted player index, and that's an integer as well. So let's compile and save this interface and close it. So I'm going to fix my spelling error. There we go. And before we are actually implementing this into the game mode, we're going to set it up in the actors that will call it. So we're going to start in our enemy base. So let's go to our enemies folder, open enemy base. And let me grab my notes in here as well. Just a sec. So what we want to do in here is add variables to begin with. So let's create a new variable and call this our game mode actor. And we're simply going to store this as an actor because we don't need the specific class to make interface calls. So we're not going to cast it to our BattleMechs game mode and then store that variable. We're simply going to store the game mode as an actor variable. And then the second one that we need is our player to attack index. So player to attack index. And this is an integer, so change it into an integer. Then we need to do a little bit of setup. So first of all, we're going to go to our event begin play. So we need to go to the event graph. And over here, as I mentioned in the comment, this is temporary until we spawn enemies from the game mode. And that's what we're going to do at this point. So we're going to get rid of this part where we set the player to attack. And we can actually just delete it. And what we're going to do in here is simply wait till our player to attack is set. And we're going to do that from the game mode when we start, when we spawn the enemy. So what we want to do at this point is simply grab a getter and we're going to check if our player to attack is valid. Hook this up to the true pin, and if this is not valid, then all we want to do is wait a little bit. So we're going to add a delay in here, set it to 0.1 second. If it's not valid, we're going to wait until it's completed and then check again if it's valid. And we're only going to continue if the player to attack is actually valid. So that's all we need to do in here. And then we want to go to our onWrap hit location die event. And let me switch my notes in here. And what we want to do in here, right at the end, before we remove the corpse, we want to get our game mode actor to call our interface event. So we do actually need to get a reference to the game mode, but let me fix that in a second. We're going to grab our game mode actor, and from here we're going to call our AI died function that we just created on our interface. So as you will see over here, it will say message in between, and the little envelope over here, those will indicate that this is a interface function that will only actually work if the targeted actor has that interface implemented. So from the true pin, we're going to hook this up over here, and we're going to grab our player to attack index and hook that up over here. So this is the index of the player that this current AI is attacking, and we're going to send that to the game mode so we can keep the array that we created where we keep track of how many AI is targeting a current player, that we can keep that up to date. So that's good to go, and we actually do need to make sure that we have a reference to our game mode, but we're going to set that when we spawn this AI from the game mode. So that's something that we're not going to do inside of the actual enemy base, and the same thing goes for our player to attack index. We're also going to set that in the game mode when we spawn this AI. So currently we don't have these variables set, but we're going to do that when spawning this AI. So we don't need to do it inside of this blueprint. So this is good to go for our enemy base. And the next thing we want to do is go to our enemy spawner. So that's in the gameplay folder, open our enemy spawner. And in here, we're gonna make sure that we're going to reset our delay. So all we need to do in here is just get rid of all of this stuff. We're gonna create a custom event in here and call this the spawner cooldown timer. So let's create a custom event, spawner cooldown timer. And this will only run on the server. So let's grab our comment bubble and say server over here. And what we want to do is give this a few inputs. So the first one is going to be the cooldown time. That's a float. The second one is going to be the game mode actor. Game mode actor. So that's an actor again, just like we did in the AI. Not sure what happened there. Actor, object reference. And the last one is my spawner index. So my spawner index. And that's an integer. So when this event is called, we're going to grab a delay, plug in the cooldown time. So we're going to wait for the amount of time specified over here. And then we're going to grab our game mode actor and call our reset spawner cooldown timer. So reset spawner cooldown from the game mode interface. So we're going to select the message function again, plug it in over here, and we need to pass on our index in the array to make sure that we reset the correct spawner. So we're going to hook that up over here. Compile and save. That's good to go, and now we can finally go back into the game mode and tie all of the loose ends together. So let's go back to our game mode, get rid of the spawner over here, framework, open our game mode. And as I mentioned a few times before, but this time we're actually going to do it, we're going to create our spawn loop. So create a custom event and call this spawn loop. And we also need one more variable to make this work, and that's our current AI count. So that's simply the amount of AI that's currently alive in the level. And we could add all of the variables from the player AI count into one integer, but it's just easier to simply have a separate integer for that. And besides, we're not using the player AI count variable in a single player game, so we're going to keep a separate integer that will just keep track of all of the AI in the level that are currently alive. So the first thing we want to do when we start spawning is check if our current AI count is greater than or equal to our maximum AI alive. So grab current AI count greater than or equal to, and then grab our maximum AI alive. So if this is true, then we want to wait spawning the next enemy until the players have killed a few enemies and this number is actually lowered, and then we're going to continue spawning. So we're going to grab a delay. The through pin actually goes into the delay this time. We're going to wait for 0.2 seconds and then hook the completed pin back up to the branch. Then at this point we do want to spawn an actual AI, and to do that we're going to create a function that will find the correct spawner that we want to use. So let's create a new function, and I'm going to call this find AI spawner. And the first thing that we're going to do inside of this function is check if we are playing a multiplayer game or not. So check is MP game. And we're going to use local variables inside of this function. And a local variable is actually a variable that's only available and set inside of this function. And as soon as this function ends, the variable is no longer needed. It's no longer accessible from anywhere else. It's just never accessible from anywhere else except inside of this function. And if the function is not running, the variable is also not stored inside of the memory, so it's more optimized. And because it's only available inside of this function, it's also more optimized than having a variable that's accessible from everywhere else. And also every time you enter the function in a new call, all of the local variables will be reset to their defaults. So it's just more optimized to use a local variable inside of a function if you actually can. So if you don't need it outside of the function. So the first local variable that we're going to use in here is local target player index. So let's add a new variable, and I'm going to give it a prefix of LCL so that I can easily see it's a local variable in here, and then call it target player index. Excuse me. So we're going to set it over here, and because I'm using 5.5, this will actually have a little marker over here that will tell us it's a local variable. In earlier versions of Unreal, this wasn't present, so that's why I added the LCL prefix. In 5.5 you can actually easily identify it by this little V over here. So if it's not a multiplayer game, then we can simply set our target player index to 0, because we will only have one entry in the array. There's only one player, and that will be index 0. So mpgame false, simply set it to 0. If mpgame is true, then we're going to grab our player AI count array. So this is the array that keeps track of the amount of AI that are targeting a current player. And what we're going to do is drag off here, and we're going to look for the minimum of an integer array. So this will simply get the lowest value inside of the array, and it will return the index of that lowest value and also the lowest value. But in this case, we are only interested in the index of that lowest value, because that's the player that has the least amount of AI attacking him currently. So that's where we're going to send this new AI to. So that's our target player index. Then we also want to get the actual target player. So we're going to create a new local variable, call this local target player. And this is actually simply an actor. So we don't need it to be a mech. We can simply use an actor in this case. I keep hitting caps lock, pretty annoying. So let's set it over here. We want to grab both of these branches. And then we're going to grab all of our players and get a copy. And we can get it from our local target player index. So we're going to hook that up over here, and that's our target player. Now we want to get a bunch of random spawners that are not on cooldown. So we're going to use a while loop to do that. So let's drag off here, look for a while loop. And our condition in here is going to be our random spawner array. It's less than 3 for the size. So we're going to create a local variable in here and call it our local random spawner array. So this is simply so we can randomize the spawning a little bit, and we're not going to simply pick the spawner that is closest to the player or things like that. We do want to make it a little bit more random, so that's what we're going to do in here. We're going to keep this as an array of integers. So let's turn it into an integer and then right click to make it an array. So we're simply going to grab 3 indexes to define those spawners. Grab the actual array, and we're going to say if the length is less than 3, then we want to keep looping this while loop. So we're going to drag off here, do less than, and then enter 3 in here. Nope. And hook it up to the condition. And then we're going to use another local variable. So again, create one and call this our local spawner index. Or let's call it local random spawner index. So that makes a little bit more sense. This is a single integer. So we're going to grab a setter for that over here, hook it up to the loop body, and we're simply going to grab all spawners. So that's the array over here. And then we're going to grab the last index from here. So drag off, look for last index. And then we can use a random integer in range. So drag off this one, go for random integer in range. The last index is actually the maximum. integer over here, minimum is 0, and plug it in over here. And before we actually select this spawner, we need to check if it's on cooldown or not. So we're going to grab a branch, plug it in, and we're going to grab our spawner cooldown array and get the entry of this index. So get a copy of our random spawner index, plug it in, and if this is false, then we can add this to our array of random spawners, so we can actually use this spawner to potentially spawn an enemy. So we're going to grab our random spawner array, and in here we're going to add a unique entry. So add unique to make sure that we don't add the same entries multiple times. And we want to add our random spawner index to that array. So this loop body will keep looping till we have 3 entries inside of our random spawner array, and those will be random entries selected from the array, but they will not be on cooldown. So that's essentially what we're doing over here. And after we have 3 entries in that array, we're gonna get the closest entry in that array to the player, and that's where we're gonna spawn our enemy. So we're gonna grab a for each loop over here and hook it up to the completed pin of the while loop. In here we want to grab our random spawner array and loop through them. And at this point we want to get all of our spawners and then get the current index that we have selected. So we're going to grab all of our spawners, we're going to get a copy, and we're going to get a copy of the array element. So not the actual index, but the element of the array. And that's the random spawner that we selected over here. And we want to get the distance to the actual target player that we selected. So we're going to get the squared distance, because using squared distance is always cheaper to calculate than a normal distance. So whenever you can, use squared distance. And we want to plug in our target player over here. Then we need to store this inside of a local variable again, so we can compare it to the distance of the other spawners. So we're going to drag off here, promote to local variable, and this is our local temporary distance. Plug it into the loop body. Then if this is the first entry in the array, this is always the value that we want to set. So we're going to grab a branch in here and we're going to check if our array index is 0. So drag off the array index from the for loop and if it's equal to 0, that's our condition. So let's make sure this looks a little bit cleaner. There we go. So if this is the first time that we're checking the distance, we're simply going to store that distance and we're going to select this spawner till now, and then we're going to keep going through the loop. And if the next spawner has a closer distance, we're going to replace this value and also replace the selected spawner. And if we do it like that and only replace the value if it's less than the previous values, then we are going to end up with the spawner that's closest to our target player. So that's what we're going to do in here. So if this branch returns true, then we simply want to set it as I mentioned. So we're going to create a second float variable and call this our local spawner distance. Turn it into float. And then we have our selected spawner index, and we don't have that one yet. So we're going to create another local variable, and that's local selected spawner index. And turn it into an integer. So as you can see by now, we have a bunch of variables, and because we made all of them local, they are not going to clutter all of the variables inside of the actual event graph. So that's also a reason it's just tidier. But again, if this function is not running, those variables will not be in the memory, so it will also save us workload. So whenever you can, in cases like this, it's always a good idea to use local variable. So just another side note over there, sorry. So if this is the first time that we're running this loop, then we're going to grab our spawner distance and we want to set it to our temporary distance over here. And then we also want to set the selected spawner index, and we're going to set it to the array element of this for each loop. So we're going to grab the array element over here. So that's actually the index of this spawner inside of the all spawners array. So hook it up over here. And then we're going to go to the next loop over here. So we're going to get the distance of the next spawner, and then this branch will be false. And at this point we want to check if the local distance that we calculated here is less than the spawner distance that we stored here from the first entry. So we're simply going to say if temporary distance is less than our spawner distance, then we want to select this spawner, and we're going to override these values. If it's not less than, then we're not going to do anything. So only if it's true, we're going to grab our spawner distance and set it to the newly calculated temporary distance. So this means it's less, so the spawner is closer. And then we're going to set the selected spawner index as well. And we want to plug in our array element again, so grab it from over here. So that's all we want to do. And if this for each loop is completed, then the value stored inside of the select spawner index is the spawner that's actually the closest one from the three that we randomly selected over here. So that's how I kind of randomize the spawning through different spawns. So at this point we simply want to go from the completed bin, add a return node, and we're going to return the selected spawner index. So we're going to add, that's not an input but an output over here, selected spawner index. So that's an integer, sorry. And we're also going to return the target player index. So add a second output, and that's the target player index. And then we can simply hook them up. So the selected spawner index and the target player index. There we go. So at this point we have selected an AI spawner. So we're going to go back to our event graph, and we're going to call this find AI spawner function from the false branch inside of our spawn loop. Then at this point we can spawn our actual enemy. So we're going to drag off here, and we're going to spawn an actor from class. And we're simply going to spawn our right enemy, so enemy right over here. The spawn transform, we can grab it from our all spawners array. We're going to get a copy of this, and then we're going to get it from the selected spawner index over here. So let's put this up here because we're going to need it more. And then we can drag off the entry and get the transform of this spawner. So get actor transform, and simply hook it up over here. Then we're going to check if the return value is valid. So if the AI actually spawns successfully. So add a isValid pin over here, isValid node. And if this is not valid, then we don't need to do anything for this loop. So we're simply going to add a little delay over here, plug it into the not valid pin. So if for some reason, maybe because of collision, this enemy didn't spawn, we're going to wait for 0.2 seconds, and then we're going to grab this and simply loop back to the beginning over here, to the branch where we check the current AI count and compare it to our maximum AI alive. So we're simply going to keep looping this over here. Let's make it look a little bit cleaner. So that should be good. Now, if this is actually a valid spawn, then we do want to set up a few things. So the first thing we're going to do is set our spawner cooldown. So let's grab the spawn cooldown array, and in here we're going to set an array element. And by setting this boolean to true, we identify that this spawner index is currently on a cooldown. So we're going to grab our selected spawner index and plug it into the index over here. So now we know this spawner just spawned an AI and it's on cooldown. Then we want to grab our spawner to actually call the spawner cooldown timer. So let's drag in the all spawners array again. We're going to get a copy from this. And we want to get it from the index over here. So the same index that we plugged into the cooldown array. And in here we can call our spawner cooldown timer. So that's the event that we created on the actual spawn blueprint. Plug it in over here. We need to pass on the index. So when this event is completed, we can tell the game mode what index our spawner is. So we can set the cooldown back to false. And we're going to plug in our cooldown time as the spawner cooldown delay. So simply hook that up over here. And the game mode actor is a reference to our self. So we can simply hook up self over here to the game mode actor. So that will take care of the cooldown of our spawner. Then we're going to grab our current AI count and we're going to increment that because we just spawned an enemy. So we need to make sure that the current AI count stays up to date. Then we're going to check if we have an actual multiplayer game. So grab a branch in here and hook up our isMP game boolean. If this is true, then we need to set the value inside of our player AI count array as well. So we're going to grab our player AI count and we're going to get a reference, not a copy. We're going to get a reference of this entry. And the difference between a copy and a reference, if we change the reference, so for example, if we increment it with a node like this, then we don't need to store the value in the array again by using a set element node. Because we have a reference, it will automatically update the array. If we use a get copy node and then increment it, and you can see the difference over here, this is a little square and this is a circle. So if we increment it by using a copy of the array, then we need to store the result using a set array element node, for example. So if we use a reference, we can simply change the value and it will get reflected back to the array. So we want to get a reference and we want to get it from our target player index. So we're going to go back to the find AI spawner, and in here we have the player index that we want this AI to target. So we're going to grab this index, plug it in here, and we're going to increment this. So increment integer, and we only want to do this in a multiplayer game. So hook up the true pin from the MP game. And if it's not a multiplayer game, we don't need to do anything with this array because we're not using it. So then we're going to grab our spawned AI again. So let's go back over here to the spawn actor node and we want to get the return value. And we're going to drag that all the way over here. So in here we're going to set the player to attack. So set player to attack. And we're going to set the actual actor over here. So let's hook it up to the increment node and the false node over here. Let's make this look a little bit better. And then our player to attack, we're going to grab all of our players array and then get copy. And we want to get a copy from the index over here. So we're going to plug that one in. So that's the player to attack index that returns over here. So the target player index. So this is getting a bit messy. I probably want to put this green line below the blue line over here. So that looks a little bit better. So we need to hook this up to the player to attack from the enemy. So the AI knows what player it needs to attack. And then we also need to set the player to attack index. So drag off the spawned enemy again and set the player to attack index. Plug it in over here. And then grab the index over here from the green line. Hook it up as well. And then we also need to set a reference to our game mode on the AI. So we're going to drag off the spawned AI again and set our game mode actor. And that's simply a reference to ourself. So drag off the game mode actor and hook up self over here. So that should take care of all of the values that the AI needs to function. So this player to attack, that's the value that we added in begin play with the little waiting loop. So the AI will wait till it actually has a valid player to attack, and then it will execute its own logic. And after we did all of this stuff, we're simply going to wait for our spawn interval. So we're going to grab a delay, hook up our spawn interval. And if that's completed, we want to go back to the beginning of this loop. So we can use the little reroute node over here. Hook it up. So then we're going to go back all the way to our branch over here that checks the current AI count versus the AI alive, and it will keep spawning AIs until we're at the maximum AI alive, and then it will wait. So that's our spawn loop finally set up and done. Then we do need to set up our reset cooldown timer for the spawners, so the BP enemy spawners that we created. And that's actually the interface that we created earlier. So to implement an interface, we need to go to the class settings over here. And over here we have the interfaces section. We can implement an interface. So let's expand it, and we're going to add our BPI game mode interface. When we do this, on the left side, the interface will show up over here with the available functions that we can add. So first of all, we're going to set our reset spawner cooldown. Simply double click it and it will create the event on the event graph. And all we want to do in here is grab our spawn cooldown array, and we're going to set an array element. Hook it up over here, and we're going to set our spawner index back to false. So that's all we need to do. So as I mentioned over here, if we spawn an enemy, then we are setting this entry to true. And then on the actual spawner, we will initiate the cooldown. If the cooldown is done, it will call this event over here using our interface and reset the index back to false, so the spawner can be used again to spawn a new enemy. So that's what this function does. And then we need to implement our AI died event. So double click that as well. And what we want to do in here, first of all, we're going to grab our current AI count and we're going to decrement the integer to make sure that the actual value is up to date. And then we want to double check if we are playing a multiplayer game. And if we are, we also want to update our player AI count variable. So first of all, check if this is a multiplayer game. And then if that's true, we're going to grab our player AI count array, drag off here, and again we're going to get a reference and not a copy. So get a reference. And we want to get it from our targeted player index. So that's what we're going to hook up over here. And then we're also going to decrement the integer to make sure that this array matches the amount of players that are attacking this player index. So that's what we're doing over here. And usually if I use references, I add a little comment box over here to identify it's a reference, to make sure I don't forget later on, because the difference between the little square and the circle isn't too big. So we probably want to do that over here as well. So that's inner side of the spawn loop. Let's add a little comment in here that says reference. So that was a whole bunch. Okay, that should be good to go. Now we do need to make sure that we actually call this event when we start the game. So we're going to go back to our start game event that we created earlier over here. We're going to go all the way to the end, and keep in mind we have two open branches in here. So we have the false pin for the multiplayer game and we have the completed pin for the for each loop. We want to hook up both of them. So first of all, let's add a branch in here, hook up the completed pin and the false pin as I mentioned. And with this branch, I'm going to check that our all spawner array is not empty to make sure. So we're going to grab the all spawners array and look for is not empty. We're going to hook that up to the condition. If this is true, then we're going to call our SpawnLoop event, so that will start spawning AI and actually start the game. And if it's false, then I'm going to add a little print in here that will say error, no enemy spawners found, in a red color for 20 seconds, so we know something is wrong. Okay, that should be good to go, and I think at this point, let me see. This should be good. We may have, yeah, we do need to add something over here. So for our begin play event, after we get all of the enemy spawners, we're gonna add a little delay, and I'm gonna get rid of this delay later in the series, when we can actually count the current amount of controllers that are connected to the game. But to do that, we need to have a lobby so we can actually tell the game mode how many players are going to enter the game. At this point, when we launch the game, we don't know how many players are going to end up inside of this game. So for now, we're simply going to use a static delay of 3 seconds. Later in the series, we're going to get rid of this, and we're not going to have any static delays anywhere. So then we're simply going to wait till all of the players are connected. So for now, add a delay for 3 seconds, and then we're going to call our start game event. And we're also going to call our increase difficulty timer. So that should actually be good. So let's compile and save. And I think if we did everything correctly, this should work. We do actually need to place a couple of spawners in the level, obviously. So let's grab a viewport. And at this point, we can get rid of the actual AI that we just placed in the level. So let me delete all of those. And then we're simply going to add spawners. So let's go to our gameplay folder, grab the enemy spawner. And let's make sure it's rotated to the center of the level. So rotate it. And then I'm going to add a whole bunch of them around the level. So let's zoom out a little bit, and I'm going to place 4 of them on each side of the map. So hold Alt and drag to copy them. So there we have 4 of them. Then I'm going to select all 4. And copy them to the other side of the level over here. Make sure I rotate them 180 degrees again and move them. And then I'm going to select all 8 of them. And again, copy them to the other sides. So let's hold Alt and drag them. And then rotate them 90 degrees. And place them roughly in the center, somewhere over here. So now we have 16 spawners in the level, and that should be plenty. So let's hit save to make sure nothing goes wrong if it decides to crash on us. And first of all, let's hit a single player game and see what happens. So we're not having a print that tells us that we don't have any spawners, so that's good. And here actually comes the first enemy. And I think that's working. So we're getting attacked from all sides. So let's wait for roughly 30 seconds and then our difficulty should increase. And it should also tell us the new values that it decides to set. And let me add a few health by hitting 1. So I don't die. And here we have it, difficulty increased, and it will set the spawn interval to 2.5, the cooldown to 1.5, and the maximum AI is 7 instead of 6. So that actually seems to be working quite nicely. Well, let's see what happens if I die, and then the AI will keep shooting at me because we haven't implemented any of that stuff yet. So this is obviously not how it should be, and we're gonna address that in the next episode or maybe the episode after that. But this looks good for a single player game. Let's test it in multiplayer as well. So let's add a second player and hit play. And make sure that the attention of the AI is actually divided amongst different players. So let's set it up like so. And our client and host are actually being attacked by AI. So that seems to be working. And everything seems to be replicating, so we can see all the AI shoot on all of the screens and things like that. So I think we are pretty good to go over here. And it's actually very choppy, but that's because I'm also running OBS, my recording software, and it has a hard time doing all of that stuff together, especially in a multiplayer game. But I think we are pretty good to go. This doesn't look all too bad. So yeah. No errors, so that's always nice as well. At this point we have our AI spawning and it's starting to look like more of a game with each episode, so that's pretty cool. Hope you enjoyed the episode. It was pretty long and I hope it wasn't too confusing. If you have any problems with the project, you can always dive into the Discord, links in the description of the video. And I will actually upload all of the project files for you to download for free, so you can compare your code to mine and find where you might have done something wrong. And there's a whole bunch of other projects inside of my Discord as well, so it's always useful to check it out. Hope you enjoyed the video. If you did, please consider leaving a like as it helps out the channel tremendously. And then the only thing left is me thanking you for watching. So thanks and talk to you later guys. Bye bye.